Okay, this next video is on R.5 and R.6, which is rational expressions and exponents. First, let's just go over three of our basic exponent rules. The first is the quotient rule. If I have a to the m over a to the n, where those bases match, this is going to equal a to the n minus n. I go ahead and subtract those exponents. If I have a negative exponent, a to the negative n, we send that to the bottom, and it becomes 1 over a to the n. If I have an exponent of 0, a to the 0, 5 to the 0, 3 to the 0, it always just reduces to 1. Okay, let's go ahead and use those exponents with our first problem. Simplify completely with no negative exponents. The first thing that I want to do on part A is to get rid of the fact that I have this negative 2 in the denominator as that exponent. So I'm going to distribute that to all 5 terms. So my numerator is going to stay the same. 4, a to the negative 3, b to the 4th, c to the 2nd. I'm going to leave that for right now. And in my denominator, I'm going to go ahead and distribute that negative 2. So I'm going to have 2 to the negative 2, a to the negative 2. B squared to the negative 2 becomes b to the negative 4. I multiply. Same thing here, c to the negative 3 to the negative 2. I multiply, I get a positive 6, and then I get d to the 0. Okay, I'm going to go ahead and simplify this further. So again, I'm going to focus on my denominator first. And I'm going to start bringing some things up because I have so many negative exponents. Actually, first, let's take my 4 and leave it on the top. My a to the negative 3 is going to be sent to the bottom. I don't want negative exponents, so I'm going to bring that negative 3 to the bottom. B to the 4th can stay on the top, and c squared can stay on the top. Then on my denominator, I have this 2 to the negative 2. Well, that's going to come to the top, 2 to the positive 2, which is just 4. A to the negative 2 comes to the top as an a squared. B to the negative 4 comes to the top as a b to the 4th. C to the 6th stays in the bottom. And then this d to the 0, well, that's just 1, which I don't need to keep anymore. Okay, then let's start combining. In my numerator, I have a 4 times 4, that's 16. I have a b to the 4th and another b to the 4th, that gives me b to the 8th. I have a c squared, and I have an a squared. All over, what's on the bottom? A cubed, c to the 6th. Now let's see if I can combine anything else. I have the 16, that's got to stay. I have a b to the 8th, that's got to stay. I have a c squared over c to the 6th, so I subtract those, I get negative 4. That's going to stay on the denominator. I've got 4 more c's on the bottom. And then I have a squared on the top, a cubed on the bottom. I have 1 extra a, so I'm going to throw that in the denominator. So I get 16 b to the 8th over ac to the 4th. Okay, moving on, let's go ahead and try example B. Example B has this big exponent of a 20, but what's nice is when I distribute that, again, I'm going to multiply. So I get x to the 1/4 to the 20th. Well, 1/4 of 20 is just 5. And then y 2/5 of 20 is just 8, all over x squared. Multiply that by, this entire thing is being raised to the 0, which is just 1. But I still have the denominator, so I'm going to go ahead and distribute that 4. I have negative 3 to the 4th, y to the negative 20th. Continuing with that, let's go ahead and condense. I have an x to the 5th over x squared, that gives me x cubed, and then y to the 8th, times negative 3 to the 4th is a positive 64, and then y to the negative 20th is going to come up to the top to be a positive exponent of 20. Now I'll go ahead and multiply these together. Remember, this is still over 1, if that helps you to leave that. And when I go ahead and distribute, I'm going to get my x cubed, my y to the 8th times y to the 20th is y to the 28th. I add my exponents, all over 64, and there's my final answer. Okay, moving on to example 2. Go ahead and look at 2a. I want to simplify this. One thing that I just want to mention, big idea with these is you're always factoring first. Okay, factor first. So first thing, x squared minus 16, well, that's the difference of squares. We get x plus 4 and x minus 4. All over, I'm going to factor on the bottom, what multiplies to 24 and adds to 10. Well, that's 6 and 4. And And then you'll notice right away, well, I've got an x plus 4 on the top, and I have x plus 4 on the bottom. Those are going to cancel out for me. All we end up being left with is x minus 4 all over x plus 6. I cannot cross out those x's. That's my final answer. Part B, I have a 2y squared over 9 times 27 over 8y to the 5th. I'm going to start condensing first. I'm going to go ahead and notice, well, 2 goes into 2 once. 2 goes into 8 4 times. 9 goes into 9 once. 9 goes into 27 3 times. And now before I start getting too confused with all the slashes, I'm going to start combining. So 1 times y squared times 3 gives me 3y squared all over 4y to the 5th. And then I can reduce that once more. The 3/4 does not condense, but I have a y squared over y to the 5th. 2 minus 5 is negative 3. I'm going to send that y to the bottom, so it can be a positive exponent, 3 over 4y cubed. Final answer. Oops, I don't know where that keyboard came from. Okay, now part C. Part C here, same thing, factor first. Always factor first, just got a little bit bigger. I'm multiplying two of these rational expressions. So x squared minus 9 is x plus 3, x minus 3. On the bottom, the only way I can factor this is by taking out a GCF. So I pull out an x, I'm left with x minus 5. And then I'm multiplying this. I'm going to just make this one big fraction bar. I'm multiplying it by x minus 5 all over 4x minus 12. I'm going to factor again, take out that GCF of a 4. You're left with x minus 3. Same thing. What can you cross out? What cancels? X minus 3 on the top, x minus 3 on the bottom. X minus 5 on the top, x minus 5 on the bottom. Then go ahead, what are you left with? Only thing on the top is an x plus 3. And then on the bottom, we have a 4x. And there's our final answer. Okay, last one on the front page here. I have a big rational expression that is being divided by another one. Instead of dividing, I'm going to go ahead and multiply by the reciprocal. That'll make it a little bit easier for us. Still, I'm going to go ahead and factor first. I'm going to take this first term, 3x squared plus 11x minus 4. That factors into 3x minus 1 times x plus 4. All over, on the bottom, I can factor out a GCF of 8x squared, and I'm left with 3x minus 1. Now, instead of dividing, I'm going to change that to multiplication, but I'm going to go ahead and multiply by the reciprocal. So we're going to flip this entire thing here. Okay, multiply by the reciprocal. So now my numerator is going to be 24x to the 4th minus 36x cubed, which at the same time I'm going to go ahead and start to simplify that. So I'm going to pull out their GCF of 12x cubed, and I'm left with 2x minus 3. Then on the bottom, the denominator is now what used to be the numerator, because again, I'm multiplying by the reciprocal. I pull out the GCF of 9. I'm left with x plus 4. Okay? Now, same thing. I want to go ahead and cross some things out. What is on the top and on the bottom? I have a 3x minus 1 and a 3x minus 1. Those reduce. I have an x plus 4 and another x plus 4. Those also reduce. Let's go ahead and combine these before I start to combine too much else. So I have a 12x cubed over 2x minus 3 all over 8 times 9 gives me 72 in the bottom, x squared, and that's about it. Okay, so continue reducing things. 12 goes into 12 once, 12 goes into 72 6 times. I have x cubed divided by x squared. That's going to leave me with just an x on the top and 2x minus 3. All over, all I ended up with on the bottom was a 6. So we get x times 2x minus 3 all over 6. If you want to go ahead and distribute that numerator and say 2x squared minus 3x over 6, that would be fine as well. Okay, let's flip to the back and do example 3. We are now adding rational expressions instead of multiplying and dividing. So when I go ahead and add any type of fraction, I need to have common denominators. Okay, that's a very crucial step. So I'm going to look at these and I'm going to say, well, they're big expressions that are on the bottom. So let's, again, factor first. Okay, so I've got a 3x on the top. We're going to leave that alone. and then I'm going to factor the bottom. I have an x plus 4 and an x minus 3. Okay? Then I'm adding x over x squared minus 16. Again, go ahead and factor that. Difference of squares gives me x minus 4 and x plus 4. Okay, I can't combine these yet. They don't have common denominators, but they have a couple factors that are similar. They each have an x plus 4. Then that guy has an x minus 3, and the second one has an x minus 4. So I need to go ahead and add an x minus 4 in the bottom of the one on the left. Well, if I do that, I need to multiply my numerator by it as well. Okay, same thing with the right. It's missing an x minus 3. So if I multiply my denominator by that, I've got to multiply my numerator by that as well. And now let's start simplifying this. So on the top, I'm going to go ahead and distribute this 3x to both terms. So I get 3x squared minus 12x all over that common denominator of x minus 4, x plus 4, x minus 3. And then I can start adding these. I now have these common denominators. So just keep going with that same big fraction and add on the second piece of my numerator, which is x times x gives me x squared, and then a minus 3x. Okay, last step is let's simplify. So I want to go ahead and combine my like terms. I have a 3x squared and a regular 1x squared gives me 4. And then I have minus 12x minus 3x leaves me with minus 15x. All over, same thing, I have that denominator, x minus 4, x plus 4, x minus 3. There is no need to multiply that entire thing out and distribute. You can leave your answer just as is. All right, last one that we're going to do on this video is part B. Now I'm going to subtract two fractions, and I want you to look at those denominators and think for a second about how similar they appear. I have 2x plus 1 over x minus 2, and then I have 3 over 2 minus x. The only thing that's different about that second denominator is the sign. Instead of a negative 2, it's positive. Instead of a positive x, it's negative. So what I want to do to make our lives a little bit easier is I'm going to leave my first fraction alone, and then I'm going to go ahead and subtract 3 over, instead of 2 minus x, I'm just going to simply factor out a negative 1. Okay, what happens when I factor out a negative 1? I'm left with negative 2 plus x. Well, now my denominators match. Now I have this x minus 2 again. And remember, it doesn't matter if I put the negative in the bottom or the top of a fraction. So let's go ahead and rewrite that once more. Subtracting, I'm going to just rewrite this where I pull this negative up to the numerator. So it's a negative 3 over negative 2 plus x. Right? Now I'm subtracting a negative. Well, that's the same thing as just adding. So now our math has become a lot easier. And again, I do have common denominators. I could rewrite this as x minus 2. That is the exact same thing, interchangeable. Okay, and now since my denominators match, I can go ahead and combine. So I have 2x plus 1 plus 3 gives me 2x plus 4 all over x minus 2. And again, leaving the the numerator like so as 2x plus 4, or you could even factor out the 2 if you wish. Either way is fine. That concludes our video for R5 and R6. We will work on the complex fractions in class tomorrow. Please bring any questions you've got to your teacher.